Hi everyone, welcome back. We're now looking at the question. Our question is find the integral of the function e to the sine x from 0 to pi by 2. And we are looking at an error value of epsilon equals 10 to the minus 5. So let's just first go back to what we know. We know that what our function is. So over here we have our f of x, we have our a, we have our b, and we have our epsilon. Let me just do some color with these. We've got our a, we've got our f of x, we have our b, and finally we have our epsilon. So with those in mind, we know that we need to find what this is. We need to find our error term. So first thing we know is, as we went over earlier, we have our delta is always going to be less than or equal to. Our delta term is h to the 4 b minus a times k all over 180. And we need to figure out what our h is, because that will determine what our number of intervals are to make this true. Because remember, our h term can be rewritten with reference to n as h times n is equal to b minus a over 2. And let's just do some quick color coding of this. So we have got, I'm just going to pull in we don't have our function listed as yet, but we have got our a, we have got our b. We need to figure out what our h is. We've got our b here, we've got our a here. Let's make h magenta. So h over here, something that we need. And if we go back to just written terms, we know that has, by definition, we know that that's got to be less than our epsilon. Now, epsilon we know is our dark green over here. So just in terms of the logic to the question, this is what we're looking at. Our k value, which I'm going to just make light blue here, our k value, we must also remember, as I went over earlier, our k value is equal to the max from a to b of, this is the 4th prime of x, and this we're going to set in an absolute value. So with that in mind, we can actually start highlighting that and color coding this. So we have our k over here, we have our max from a to b, and we have this is not strictly our green. I've got a better way to represent this. We still need to apply our 4th prime. The final thing that we're going to just need to remember is we need to figure out what our n is, because that will tell us how many intervals we need to divide. And remember the one very key point, and this is the case with almost all of these approximation methods. I'm not going to say all just in case I'm not thinking of one offhand. But remember, our n is an element of the integers, because we need to be able to have a number of intervals that is set. So with this in mind, let's start breaking it down. We have each of our equations. The first thing that we want to determine when we're looking for our k value over here, we need to consider the maximum value k is going to occur at either, I'm going to go max of f for x, it's going to occur either when x is equal to the minimum boundary condition, the max boundary condition, or when f of x, the fifth prime, is equal to 0. And this last one is the first derivative test, if you remember it from your calculus. The first thing to go about doing, we need to get our fourth prime of f. And this, it's just simple differentiation. It's quite straightforward. Everything that you've done in the past, it's just a little bit laborious, so I'm going to land up doing this quite quickly. So we know that our f of x is equal to e to the sine of x. That means that our f of x first prime is going to be equal to e to the sine x, chain rule it, cos x. Our f prime prime of x, we can then just look at this and we can go, we're going to first of all chain rule this, e to the sine x times cos x. But remember, we've got a product rule, so cos x times cos x, we've got cos squared x, plus, then we have product rule, so e to the sine x, this is f prime g plus g prime f, so e to the sine x times derivative of cos x is minus sine x. That we can rewrite quite simply as e to the sine x, open brackets, cos squared x minus sine x. Just going to make our life easier for the next step. Let's go f prime 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 of x. This is where we start to get a little bit messier, but it's still fine. We have e to the sine x, chain rule it, cos x, multiplied by, now we're going to multiply by the raw value in here, which is going to be cos squared x minus sine x. That's f prime g, where that's f is on our left, and g is our cos squared x minus sine x, plus, and now we have fg prime, or g prime f, which is going to be e to the sine x, multiplied by derivative of the inside, which is going to be 2 cos squared x becomes cos x. Well, cos squared x becomes 2 cos x multiplied by the cos x, which is going to be minus sine x. And then we can take the derivative of the sine x, which becomes minus sine x, which becomes minus cos x. We can simplify this a little bit just to make our lives a bit easier. We know that this term over here, 2 sine x cos x, we know that that's an identity as well. So we land up with e to the sine x multiplied by, that's going to be cos to the 3 of x minus sine x cos x. And here we've got minus 2 sine x cos x, so we've got minus 3 sine x cos x, which is, according to identity, minus 3 over 2 sine 2x. And then over here, our last term over there is minus cos of x. And then our fourth f prime, f to the 4 of x. Once again, we get a little bit messy. We go e sine x, chain rule it, cos x, multiplied by, we've got this basic piece here. So because we can see we've got a pattern where we basically have cos x times whatever our term is here, plus the derivative of our term here. I'm going to just put a bracket in here, go cos x times cos 3x minus 3 over 2 sine 2x minus cos x. Close this first bracket, and now we can just go plus. Now it's going to be the derivative of the inside. Derivative of the inside, because we're already timesing by our e on the outside there, we are going to land up with derivative of cos 3x is going to be minus sine x. That's going to be minus 3 sine x cos squared x. Again, it's just chain ruling. Cos cubed becomes cos squared, pull the 3 out, then we're going to take the derivative of the cos, And now we're going to do the next term, minus 3 over 2 sine 2x. Again, it's just chain ruling. We land up with minus 3 cos 2x. And we then land up with here minus cos x, which becomes plus sine x. And we can simplify that a bit because ultimately we want to have f to the fifth prime. We just simplify this a little bit. We have e to the sine x multiplied by, do just a bit of simplifying, cos r to the 4x. I'm going to just go through this very quickly. I'm not really going to talk my way through it, but we can just do some multiplication in here, add these things up over here. I'm going to just put my bracket in there because I missed it. But we land up with cos to the 4x minus, that would be 6 sine. I'm just expanding our identity terms as well, so our cos 2x and our sine 2x. So that we land up with minus 6 sine x cos squared x minus 4 cos squared x plus 3 sine squared x plus sine x. Once again, we can now do our final term, f to the 5 is equal to, now I'm wanting to try keep a term outside wherever possible, because now we're looking to try factorize it. And here we go. I've done some simplification as I was going along, just to make life a little bit easier to understand. The main thing and most important thing that we can see over here is we have outside the bracket e to the sine x and cos x. So remember our interval of AB is equal to 0 pi by 2. So we're only interested in terms within that value. So we can run a Newton-Raphson method on this. And by running a Newton-Raphson, what we're able to identify is that we should have, this term should equal 0 within this range. And here we have our f to the 5 equation. We can see that we will have a 0 in this equation at pi by 2, because pi by 2 makes cos of x 0. We can also perform a Newton-Raphson method on this. If you're unsure what that is, you need to go back to your notes and just revise. So we can perform a Newton-Raphson on this, and if we do that, we will find that it also equals 0 when x is equal to approximately 0.4716, roughly there. Now, because we have an interval from 0 to pi by 2, that is our a to b. Let me just do some color coding. We have our a, which we can see as red, orange, not red. We have our a, and we have our b. We just so happen to have found that our 1, 0 happens to coincide with our b. That is not always the case. Most of the time that won't occur. But that means we need to check 0, 0.716, and pi by 2. Because we have to check boundary conditions, and we need to check any zeros. So when we plug that into our f of 4 equation, because we're looking for a max value, an absolute value max value, we get for x equals 0, we get, I'm going to put a colon here. When x equals 0, we land up getting, it should be approximately 3, I believe it is. Let me just double check that. We look at our 4 equation, because sine of x is 0 when x is 0, so this term here becomes 1, and then all of our other cascading terms over here, so we can look at cos 4x, becomes 1, minus 6 times 0, minus 4 times 1, plus 3 times 0, plus 0. So that lands up giving us a nice term, absolute value. So it's minus 6 times 1 plus minus 6 times 0. Okay, that is eliminated. Cos of 4, that's 1. Minus 4, so that's 1. Minus 4 is minus 3. We're taking the absolute value, so we get 3. When x is equal to 0.716, we can plug that into the equation. I'm not going to go through the whole process for time constraints, but we should be getting approximately 5.724, around there. Finally, our last boundary condition, which also happens to be a turning point, x equals pi by 2. Plug that into the equation, and we get 4e, which is equal to 10.873127. We get approximately that. Now, we are looking for the largest value, and we can see that that is 4e. So therefore, we can conclude that our k value is equal to 4e. We know that our k, color-wise, we're looking at light blue. So let's just color code it quickly. K is equal to 4e. With that in mind, we can now, let's bring down our next equation. So I'm going to just grab this and bring it down. This is what we're working with. So we're trying to figure out what our x should be. So when we substitute into this equation, we have our h to the 4, open brackets. Our b we know is pi by 2, minus our a, which we know is 0, multiplied by our k, which we know is 4e, divided by 180, which is a constant. It's got to be less than or equal to our epsilon, which we know is 10 to the minus 5. Color coding this, just for clarity, we have our 10 to the minus 5, we have our 4e, we have our a, which is 0, we have our b, which is pi by 2. And our h, which is what we want, is over here. Rearranging the equation and solving for h, so we'll bring pi by 2 minus 0 to pi by 2. So we'll bring 4 times pi by 2, 4e times pi by 2 over 180, bring it over to the other side, and then we will land up with h4. It's got to be less than or equal to, that's going to be 10 to the minus 5, multiplied by 180, divided by pi by 2 minus 0, we can just leave it as pi by 2, multiplied by 4e. And if we just take a fourth root on each side, or take both of them to the power of a quarter, we can then state that that is going to land up 0.10132. Approximately that value there. So we now have what our h should approximately be. Bear in mind, I'm just going to rewrite this for clarity. Taking a fourth root both sides, we land up with h on this side, less than or equal to 0.10132. Important to note, we're still working with an inequality. So we haven't determined what our h is yet, we've determined what it has to be less than. So if we go back to our next equation that we had earlier, pull in our next equation here, our hn, bring that down here, because we're wanting to know how many things we need to divide it into, how many intervals. So if we're going to substitute these in, we land up with, let's start by rewriting this. Let's write in terms of h, because we've got an h here. We know that that's going to be equal to h b minus a over 2 times n. We can just do a little bit of rewriting like that. So now we know that, let's flip this around. So now we have 0.10132 has got to be greater than or equal to h because of this equation here. And we know that h has got to equal that. So it equals b minus a over 2n. Now let's remove this the equals in the h, and we land up with 0.10132. It's got to be greater than or equal to b, which we know is pi by 2, minus a, which we know is 0, divided by 2 times n. Once again, we rearrange the equation, bring the n to the left-hand side, bring this term down to the bottom, and we land up with n has got to be greater than or equal to pi by 2 divided by 2 times 0.10132. And if we land up multiplying that out, we land up with a term which is approximately 7.75. Remember though, I'm just going to quickly color code just so that we are all on track. We have our H over there. We've got our B and our A. Let's do A, A, A. We have our B's, which we've done in blue. Because our B minus A is 0, I'm just going to highlight that over there nicely to make it clear. I'm not going to be highlighting this in purple yet because this is not quite confirmed to be our H as yet. It's an inequality still. So if we highlight our N over here, and we've got our N appearing over here, that's the one H here. So when we land up working all of this out, we land up with an inequality. Once again, I'm going to write it out for clarity. We know that N has got to be greater than or equal to 7.75. But remember, we know that n is an element of the integers. As such, the first bigger integer than that, we can then state that n is equal to 8. We need to make n equal to 8 or something larger than that. Because we don't want to make more work for ourselves than we have to, we're going to stick with 8. Now we do have a final value for n. So let us highlight our n's over here. What we can now do, we can go back to our equation that we have over here. I'm going to copy it down. Now we want to figure out exactly what our h is. So our h is going to be equal to b, which is pi by 2, minus 0, which is our a, all over 2 times 8. We should be able to do that in our head. 2 times 8 is 16, times another 2 is 32. So our h is equal to pi by 32. That is our final h. That is what we're going to be utilizing. So now we have to look at what we have. Let's go back to our equations. We have been hunting to find out what h is because that's what's going to define what our intervals need to be. We now have h. Now all that's left is for us to set up our equation. We know our a to b, and now we know our e to the sine x. This is where the tedious part comes in, which is just making the table. So when you make your table, I generally recommend that you have an I term just to keep yourself in check, have an X term and a Y term. And you're just going to be, your Y term is equal to your f of X. And here we're going to have, remember you always start with 0 on the I, so you're going to have 0, 1, 2, 3, and so forth, all the way up to your final term. Your X, just so that you're following where we're coming from, we've got 0, pi by 32, 2 pi by 32, I'm not going to simplify it, 3 pi by 32, keeping it unsimplified just for clarity purposes, so you can see the change in h. Our y, if we were to substitute into the equation, we get 1 here, then 1.103, then we have 1.2154, 1.3368, and you need to do this for each of the terms. I'm going to jump up to our higher end. We've got term 15, and then we've got term 16. Remember 16, just for where you remember, is your 2n. So our term 15, we're going to have 15 pi by 32. Term 16 is 16 pi by 32, which we know is also equal to pi by 2, which is our b. So if we plug these into, we should be getting 2.7183, and our 15 is 2.7052. With this data in mind, we now just need to utilize the equation that we know we have to use. And I'm going to bring that down over here. Create a new page. And I'm just going to color code as well, just to make life easier. We have our, take our equation. So we have our f of x over here. We have got our x. We haven't got a color term here. So we have that equation there has got to equal this over here. Remember, it is an approximate equal. And all we're going to be doing is substituting in. So by doing that, I'm just going to write out a couple of terms so that you get an idea. This lands up equaling our h, we know, is pi by 32, divided by 3. And we have our y0. We have a look at our y0, that's 1, plus our y of 2n, that's our final term, which is 2.7183, plus 4 times our y1, 1.103, plus, now we're going to look at the sigma term, so this we're basically going to be going term 0, 1, then we're starting at 1, so 2 times 1, so 2, 3, 4, 5, 6, 7, 8, 9, all the way up until n minus 1, which is going to be, n is 8, so that's going to be up to term 14. Bear in mind, we have got n, that's n is equal to 14 over here, and we're going to have 15 because this is 2i plus 1. So we land up with 2 times, this will be 1.2154 plus 4 times 1.3368 plus, we're going to continue, I'm going to put the dot dot dot, plus term 15, I'm going to be looking at that, which is going to be, remember, we always end on an odd term because 2i plus 1 plus 4 times 2.7052. We plug that into our calculator and we hit equals. We come out with a number that is approximately 3.10437901. And if we compare that with our number by doing an actual integral of this, we find it is very, very close. I believe it should be approximately 10 to the minus 8, which is within our error range. Bear in mind that we aren't working it out to exactly 10 to the minus 5 error, because we are making sure that it's at most that error. And that error, when we say at most, that at most will be dependent on the equation itself. But that is the method. It may seem quite long. It is quite tedious. The painful part is the integration, but the principles are exactly the same, and you do not just need to follow through with your basic equations. Every question should function the same. If you have an h, life is very straightforward. If you don't, then you have to do your derivative calculation. Anyways, I hope that helped. Thanks and good luck.